Hey everyone, I wanted to go ahead and just take a quick look at what the expectations are going to be for the second part of our Newton's Law quiz, which is going to revolve around force diagrams. And so our specific learning objective says I can analyze and evaluate force diagrams or free body diagrams. And then we've got our 4 levels here. And so I want to go over these levels kind of one by one and make sure that we kind of understand the expectation for what you have to do at each level. So for our level 1 example, okay, the level 1 example, level 1, here we go, says I can identify the forces acting on an object and create a free body diagram with those forces. So let's say that I have a box, and I have a box that is being pushed by a tiny person, and it's being pushed over to the right. Okay, so here's our scenario. Earlier this unit, I gave you guys a list of forces that you would be responsible for, and then later we used that list of forces when we did the hockey player example to identify something called a free body diagram, which is where we add arrows to identify where my forces are. And so let's go ahead and take a look at the box. My box is definitely experiencing a force of gravity. There's my force of gravity, like that. And because it's experiencing a force of gravity, gravity pulls down on the box. Let's assume that our box isn't just floating, it's on the ground. Okay, gravity pulls down on the box. The box presses into the ground. Because of Newton's third law, the ground must apply an equal and opposite force back up. And so I'm going to have a force that goes up this way. And this is what we referred to as our normal force. There's our normal force right there. Okay, now that's all good, except I have that little guy pushing, and so I'm going to have an applied force. This is the force of my little person, which I'm going to refer to as an applied force, or F sub A. Okay, he's pushing that way, trying to slide the box, and he might be successful, he might not. Whether he is successful or not will be determined by whether he can overcome our force that resists motion. That's our force of friction. So there's our force of friction. And here is our applied force. So if I just give you a basic scenario and you can identify the forces that are acting in that scenario, you will get a 1. That's what I'm looking for you to get a 1. Now let's go ahead and kind of take this thing, and I'm going to duplicate it and move it down. Let's talk about what you have to do in order to get a level 2. Okay. So for level 2 on this test, and I go back up to my rubric and I can read it, it says I can find the net force given a free body diagram. So if I want to look at what I've done with my free body diagram down here, now that I've created it, let's go ahead and just add some numbers to it. Let's say that I have a gravitational force of 200. I have a normal force of 200, an applied force of 500, and a friction force of 100. Okay, so now the setup has only changed is I've added some numbers here. And I gave you a couple of rules that I told you that you should be kind of aware of or keep track of. And that is, if I've got arrows in the same direction, I can add them together. If I have arrows in opposite directions, I can subtract them. So what I'm going to do is I'm going to look at my diagram and I see, I have a 200 Newton force up and I have a 200 Newton force down. And I'm going to go ahead and subtract those. 200 minus 200 is going to be equal to 0. I think everybody's pretty familiar with that one. And so I'm going to go ahead and just cancel those forces out. I don't have any forces in the up and down direction. They just cancel out automatically. Now, in the left and right direction, I have a 100 Newton force to the left and a 500 Newton force to the right. So I'm going to go ahead and subtract those. I'll take my 500 minus my 100. My computer wants to do this for me, okay? And I'm going to get a 400 Newton force. So that 400 Newton force is going to be the net force, what we call, on our object. It's the only force that I have left over. So after I cancel this one out and this one out, now all I have left is a 400 Newton force going to the right direction, 400 newtons. And this is what I refer to as our net force, okay? It's the only force that's left over after everything cancels out. And that's going to become important later. So that's our level 2 problem. Not terrible. We can definitely do this. Now, level 3 says I can analyze and evaluate a force diagram and use it to predict a change in the motion of an object. So if I once again take our original free body diagram, I'll copy it, just move it down here. Let's talk about what that means for level 3. Oops. There we go. All right. Level 3. We did our evaluation up here in level 2, and we found that we had a net force of 400 newtons, and we were moving in the rightwards direction. Okay. Now, the thing that I need you to know here is that an unbalanced or a net force creates a change in motion. And hopefully, some of this is starting to sound a little bit familiar, because anytime we talk about a change in motion, this thing right here, I want you guys to start thinking about this as an acceleration. Okay, we talked about acceleration being a change in motion. So anytime I have an unbalanced force, that means that my object is going to be speeding up or accelerating in the direction of that force. And so if I go back and I look at my little person who's pushing the box, I know that it's going to be accelerating in this direction, because that's the direction that I have a net force in. And so the only real difference between the level 2 and the level 3 for this problem is that you should be able to tell me that because I have a net force, I am going to get an acceleration that pushes in that direction. Okay, so it's going to overcome the inertia, that was Newton's first law, and it's going to move it in that direction. So this is that outside force that we were talking about. Now the final solution, or our level 4, is going to take all of this and we're going to apply some math to it. So let me go ahead and copy this little thing right here, and let's work with our more advanced problem, and let's talk about what I'm expecting for a level 4. So level 4 is going to take our understanding of free body diagrams, and I'm going to add what we understand about Newton's laws. And so the only little piece of information that you will get added for level 4, and if I go back up to my rubric, you can see it says I can apply concepts to create a free body diagram and perform calculations. This is the big deal right here. We're going to perform calculations from a given or self-created scenario. So here's my scenario. I still have my small man pushing a very, very large box, and I'm going to tell you that this box is going to be 200 kilograms. This is about a 450-pound box, very big box, okay? Now, we solved earlier and we did all of our math and found out that we have a 400 Newton net force that is acting on this box. And Newton's second law says that a net force is going to be equal to a mass times an acceleration. Okay, so now I'm going to take this and I'm going to plug some numbers in. I know that my net force is going to be equal to 400, and I'm going to set that equal to the mass of my object, which is 200. I got that from the size of the box, and I'm going to multiply that times some value of A. So if I want to find the acceleration of the box, what we're going to do is we are going to divide both sides by mass, 200. On this side, this cancels out. And what I will wind up with is 400 divided by 200 is 2, and that is going to be our value for A. So what that functionally means, if I'm kind of reading my math correctly, is that the box will accelerate at a rate of 2 meters per second squared. So this tells me that I'm now using Newton's second law of motion. on my free body diagram, which I've already simplified, and now I can actually use it to solve problems like finding the acceleration of an object. So that's what you would have to do for a level 4. So kind of walking you back through just to make sure we're kind of staying consistent. Level 1, we are simply identifying what forces are on the box. Level 2 is we can solve for a net force on the box by adding and subtracting our arrows depending on what direction they're in. For a level 3, you can tell me that because I have a net force, the box is going to accelerate in that direction of the net force. And then level 4 is you should be able to solve for the acceleration by using Newton's second law of motion. So I hope you found this to be helpful, and we'll be practicing this a little bit more in class, but this is exactly what I'm going to expect you to do on the next assessment.